Hello, this video is to help you out on homework 6, week of February 12th. In problem 1, write the expressions in simplest form. Remember, the negative exponents take the reciprocal or flip to the other side, which really means flip to the denominator. So let's do a quick review of zero and negative exponents before we get started with some of these problems. It's important to think back to examples like this one, where you're looking at an exponential relationship with a common base like 2. And as we have 2 to the first is just 2. 2 squared is 2 times 2, that's 4. 2 to the third is 2 times 2 times 2, that's 8. We can see that we're multiplying by 2 at every step. However, to figure out what zero exponent and negative exponents would mean, we have to think about the reverse. We have to think about dividing, going backwards as we're going back up. So as we're going back up, we're dividing by 2. Let's think about that. So from 8 to 4, we divide by 2. From 4 to 2, we're going to divide by 2. We're going to repeat that pattern. So when you divide 2 divided by 2, you get 1. Zero exponent, anything to the 0 power is 1. That's really important to know. If we continue to divide by 2, then we have 1 divided by 2, which is a half. We can see that 2 went into the denominator. Continue to divide by 2 to see what happens. What is a half divided by 2 again? And you get 1/4. This is the same as 1 over 2 squared. And our last one is 1 over 8, or 1 over 2 to the third. So the number in the exponent stays the same. It's still 3, right? But it's in the denominator and the negative goes away. Keep this all in mind. We need to know zero exponent and negative exponents. So for example, number 1, we have x to the 0 power. That would just be 1. And x to the third, we can't simplify any further. So this is really 1 times x to the third, or just x to the third. In part B, we have x to the third times x to the negative fifth. That negative exponent will take x to the fifth to the denominator. So we have x to the third remains on top. The one with a negative exponent goes to the denominator. Once we have that, we can expand out. These are the same bases. On top we have 3 x's being multiplied, and on the bottom we have 5. Right here we can see that we can cancel 3 of them. We're left with 1 over x squared. That's the answer. In the next problem, we have a 5. These are all being multiplied, first of all, so just remember that. Even though there are parentheses, that doesn't really matter when it comes to multiplication, when there's no addition or subtraction going on. So we can combine like terms. We have a 5 and a 7. 5 times 7 is 35. And we have a cubed and just an a, which would be a to the first. So let's write that out as 35. And then we have a to the third is 3 a's. A to the first is another one. We have a total of 4. You could just add those exponents. So 35a to the fourth is simplified. It's shorter. Everything's combined. That could be combined. Let's keep going here. So for our next one, you want to expand out. This is really similar to part B, where I expanded out all those x's and canceled. In E, we have negative exponent here again. So we can move it to the denominator. And it's only on the w. It's not on that 15. So keep the 15 on top. On the bottom, keep the 5. Keep the original w. And now we have that w squared is going to go to the denominator, and the negative exponent is not negative anymore. On the bottom, you might think, well, we have a w and we have another 2 of them, all being multiplied. So on the bottom, we'll have w to the third power. And what's 15 divided by 5? That's 3. That stays in the numerator. So we have 3 over w to the third power. For part F, I would expand this out so you can see what's happening. We have 2y over x times 2y over x. times 2y over x. When we multiply fractions, we multiply across. So we can rearrange. We can think, hey, let's take that 2 times 2 times 2. That's 8. We have y times y times y. That's y to the third. And x times x times x. X to the third. There's nothing to cancel. Simplifying in this case just meant remove the parentheses. In part H, we're going to put, we're first going to write out that we have 2 of these, because let's do this outside exponent first. So we have x to the negative 5th, and we have another one. Both of these with negative exponents, we want to get rid of the negative exponents. So this goes to the denominator 1 over x to the 5th times 1 over x to the 5th. This is a lot of writing, but I think I'll just go ahead and show you guys what this really is again, multiply across. So on top, you have just 1. On the bottom, you have all these x's. How many x's are there? And so it would be 1 over, here's x to the 5th, 1, 2, 3, 4, 5. Here's another x to the 5th, 1, 2, 3, 4, 5. Those are all being multiplied. How many are there? There's 10. So it's just 1 over x to the 10th. Part I is similar. However, there is no negative exponent to worry about, so I think you can do that one on your own. Part J looks like a ton of stuff going on. But luckily, we got a 0 exponent right here. It makes it a whole lot easier because just remember, anything to the 0 power is 1. This whole thing is just 1. Crazy, I know. Let's move on. In the next problem, it's a lot like what I just showed you because it's related to base 2. Fill in the table. As you move to the left, each number is being multiplied by 2. So as we go from right to left, for example, from a half, it says multiply by 2. So a half times 2. If you have 2 halves, you have a whole. And so that's a 1 right there. Multiply by 2. We're going up. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Fill in these other parts as well by thinking division, right? Because we have to go the other way. So it's exactly what I had over here, that we took our half, we divided by 2 to get up to 1 over 2 squared, and divided by 2 again to get it to 1 over 2 to the third power. So 1 over 4, 1 over 8, and 1 over 16. Think about the pattern going the other way, and this is also exponent form. It's the equivalent. 2 to the 4th times what is going to give you 8? What are we doing? We're thinking we're dividing by 2, sure, to get from left to right. Dividing by 2, if you're dividing something in 2 pieces, you're taking a half of it. So it's the same as multiplying by a half. Multiplying by a half. So each time we do that, let's expand this out. We would have 2 to the 4th on top, and then times that 1/2, we're going to have a 2 in the denominator. If you combine these, because you multiply across, you have all 4 2's on top and 1 2 on the bottom. So one of those 2's gets canceled out, and we have 3 of them remaining. So the exponent is going down by 1, 2 to the 3rd. 2 to the 3rd equals 8. Let's continue that pattern. We have 2 squared is 4, 2 to the 1st, 2 to the 0, 2 to the negative 1st, 2 to the negative 2nd, 2 to the negative 3rd, and 2 to the negative 4th. So we have another way of looking at negative exponents. So you go ahead and explain that in the next sentence there. Part 3 is probably a little tricky. So on a snow day, we use a phone tree to notify students, something we used to do back in the day. One person calls 3 people. Those 3 people call 3 more, etc. Fill in the chart to show the number of students notified and draw a picture. So I started my picture. I did make a few mistakes at first trying to figure this out as well, and I determined that in stage 0, that's when we're talking about one person getting called, that initial person, because this has to start with somebody getting called. And so that would correspond to something to the 0 power is 1. So the number of people being called at stage 0 is 1. At stage 1, that's when that one person calls 3 people. So we have 3 people, 3 new calls. So I filled in the table so far with a 1 and a 3. Moving on to stage 2. Each of these people are going to call 3 people. So branch out your tree. This tree is going to get pretty big. So we have 3 people here. Let's keep on branching. And here I have a total of 9 people. That makes sense because it's 3 times 3. Now each of these is going to branch out again. So we're going to have 3 for each of these. On your own, go ahead and make that tree. It's going to be a little crazy, but everything here is being multiplied by 3. So we have 9 times 3, which is 27. And then coming on up, we're going to do it again. That tree is going to get crazy. You're going to have 81 new people being called.